good day everyone. I will discuss the finite state machines. So, introduction. In digital electronics, many systems and circuits are built using the concept of finite state machines. Or the FSMS. An FSM is a model of computation that consists of a limited number of states, and the system moves between these states depending on inputs. FS, FSMS are commonly used in sequential circuits like traffic lights, vending machines, and control systems. The traffic light example. To understand the finite state machines, let let us consider a traffic light system. The light can be in three states: red, green, or yellow. So at the start, the light is red, and after a certain time, it transition to color green, and also then if it is transition to green, then moved to then it moves to yellow. So finally it goes back to red. So the input that controls this transition in a timer. So if t is equal to 0, so the light stays in the same state. If the t is equals to 1, the light changes to the next states. So this cycle is repeated continuously. So the states can also be represented by binary outputs. Like for the example, red is equal to 00, and green is equal to 01, and yellow is equal to 10. So this way, the FSM truth table not only describes how the light changes, but also control which lamps is turned on. So this type of finite state machine, where the output depends only the states, is called a Moore machine. So the next is the pollution detection example. So a second example of finite state machine is when we consider stop and go traffic states. So here we use two inputs: timer, timer is timer timer tells when to switch state. So track sensor, or the TR, detects if trucks are waiting. So the the finite state machine works like this. So if the state is stop and TR is equals to 1, there is a risk of pollution between trucks are waiting too long. In this case, the output is 1, pollution warning. In all other cases, the output is 0, which is equals to no pollution. So this machine is different from the traffic lights because of the output depends on both the state and the input, or the TR. So this is called the Mealy machine. So Moore versus Mealy FSM. So Moore machine, output depends only the current state. So for the example, the traffic light system. So for the Mealy machine, output depends on the current state and inputs. Example of the pollution detection system. So both machines can be implemented using flip-flops to store states and logic gates to process the transition. So for the conclusion, finite state machines are powerful tools in digital electronics. So they allow circuits to change behavior based on inputs and previous states. So a traffic light and a good example of more finite state machine, where the light depends only on the current state. On the other hand, a pollution detection system is an example of milli-FSM or milli-finite state machine where the output also depends on sensors inputs. So the finite state machines are widely used because they provide a clear and systematic way to design a digital system that need to respond a sequence of events.